All right, so this one is going to be our integration by parts. And so we need to just write out what u and dv are going to be. So u is going to be x, dv is going to be f prime of x dx. And again, if you feel like you've gotten those backwards, it's just not going to work out when you go to substitute in the problem. So you can always flip it around. So derivative of x is just 1 dx. And here we're going to do the antiderivative to get from dv back to just v. And so that will just be f of x. So integration by parts, it is u times v. So that's just going to be x f of x minus v du. It's going to be integral v du. So that is f of x dx. And for this, both of these, we're going to evaluate from 2 to 5. So I'm just going to put a such that bar in here. It'll be such that 2 to 5. And then this integral is also going to be 2 to 5. And that's where this piece of information they gave us over here comes in. They're telling us this integral from 2 to 5 f of x dx, this whole thing is equal to 14. So that's where that fits in, that they're giving that to us. And this one, we just have to evaluate upper boundary minus lower boundary. So plugging in 5 for x, it's going to be 5 times f of 5, which we can get from the table. So f of 5 is 7 minus our lower boundary. If we plug in 2 for x, we'll have 2 times f of 2, which just getting that from the table is 4. And then again, they said that this was worth 14. All right, so that is going to be 35 minus 8 minus 14. So let me see, 35 minus 14 is going to be 21. Minus 8 is going to be, what is that, 13? Yeah, 13 for that one, so A. All right, so again, it's u times v minus integral v du. And that is on your stuff to know sheet. All right, this one also, this is going to be on your stuff to know sheet. Again, I don't expect that you still have all this stuff memorized from months ago. This is your logistic equation. It says it's a logistic differential equation. Number of fish in a lake is modeled by this function f that satisfies df dt equals all of this. Times in months, they give you an initial condition, but you actually end up not needing that for this. They just ask, what is the limit as time goes to infinity? So remember, for those logistic equations, kind of goes up like this, and you have that carrying capacity where it, like you think of a population, in this case of fish, you know, the environment can only support so many fish, and it's where is it going to level off? So again, I don't expect that you have memorized this still, but it is on that stuff to know sheet. Your logistic equation is k times y and then 1 minus y over L, where L is that that upper limit, that carrying capacity, which in this case is 5,000. So the answer is just 5,000, which is B. Even if you didn't remember this, if you were like, oh, logistic, that's going to level off here, just, you know, it's the only number in the problem that really makes sense. You know, the amount of fish would level off at 5,000 fish. The environment couldn't support any more than that. All right, so kind of didn't have to do any work for that, which is nice. It's just that number that's right there. All right, 18, a curve is defined by the parametric equations x of t, y of t. So they gave us both of those. We want an expression for the second derivative. All right, so we got to do the first derivative first. So dy dt, or sorry, dy dx equals. So we're going to do the derivative for y over the derivative for x. So derivative of sine is cosine. So we have cosine of t squared. And then chain rule, you have to chain on the derivative of t squared, which is 2t. And then we're going to do the derivative of x, and that derivative will just be 2t. So these cancel, and we just have cosine of t squared. So that is kind of nice. That's simplified down. All right, so now second derivative, we're going to do the derivative of that, and then divide by dx dt again. It's kind of like an acceleration. You know, you have feet per second or feet per second squared. You have to divide by that derivative a second. All right, so derivative of the derivative. Derivative of cosine is negative sine. And again, chain rule, you have to chain on the derivative of t squared. And then you have to divide by the derivative of x of t again, which again is going to be 2t. And again, they're going to cancel, which is so nice. So just negative sine of t squared. So A for that one. All right, number 19. This is asking which of the following series is conditionally convergent. So conditionally convergent means this series converges, but if you do the absolute value of it, it will diverge. If you do the absolute value and that converges, that's what's called absolutely convergent. So I'm going to work out the one that's correct, and then we'll just talk about the other three and why they're not right, because I have my list of answers over here. So this one is B. So conditionally convergent means this is going to converge, but if we do the absolute value, that won't converge. So this is an alternating series because of that -1 to the k there. So I'm going to do the alternating series test, which is that the limit as k goes to infinity of this 5 over k plus 1, that has to go to 0, which it does. If you plug in a really huge number for k, that's going to go to 0. And if you plug in k plus 1, oh, sorry, that's 5 there. So if you plug in k plus 1, it'll be k plus 1 plus 1, that'll be k plus 2. That has to be smaller than 5 over k plus 1, which is also true. If you have a bigger denominator, it's a smaller fraction. So this converges by the alternating series test. Now we're going to do the absolute value of that. So sum from 1 to infinity of absolute value of this. And I'm writing maybe more than you probably would if you were doing this as a multiple choice question. I'm just trying to show all the steps and all the thoughts. You would probably skip writing that and just go, oh, if the absolute value that, it's just not going to be alternating anymore. So you can't do the alternating series test because it's not alternating anymore. The absolute value gets rid of the terms going positive, negative, positive, negative. So we're going to compare, we're going to do a comparison test. We're going to compare this to series sum from 1 to infinity of just 5 over k. Because that is a p series, this would be k to the first, so p is 1, and so that's going to diverge. P has to be greater than 1, so P would have to be bigger than that. So it converges, but if you do the absolute value, it diverges. And so that's why that is the answer. So B for that one. So if you look at the others, for A, it would go really similarly, except for that one, when you do a comparison, P would be 3, and so it would converge. So that one would be absolutely convergent. Both of these ones, I think, are going to diverge. Yeah, because when you do limit as k goes to infinity, you would get 5 over 1, which would be 5. It wouldn't go to 0. And then same thing for this one. Oh, that's a k squared. So actually, if you did a limit to infinity for that one, it would go to infinity. So those ones are going to diverge. All right, number 20. Let f be the function defined by e to the 2x. Which of the following is the Maclaurin series for f prime, the derivative of f? Okay, well, first of all, let's find f prime. So e is its own derivative. That'll be e to the 2x, and then you have to chain on the derivative of 2x, which is 2. So we want the series for e to the x, and then just do these transformations to it. I feel like there was one in one of the free response questions that we did like this, where we replaced x with something else and then multiplied it by something. It's the same idea. We're going to replace x with 2x and then multiply it by 2. Now this one was kind of nice. I was looking through this earlier too. I was like, oh, it's nice they did that. Choice A, which is not the answer, this is the series for e to the x. And remember, there were a few of them that was like, oh, it would be good if you knew these. Well, they actually gave you that. That one's e to the x. So it's not the answer, but it's kind of nice that it's written out there for you. That was sort of convenient. Like, oh, look, it's right there. So everywhere there's an x, we want to replace it with 2x. And then we want to multiply the term by 2. And so D is going to end up being the answer. If you look at that one, this one, there's nothing to replace, but you just multiply it by 2. Here, you're going to replace x with 2x and then double it. And then same thing here, you're replacing x with 2x and then doubling it. And so that's what's going on in choice D. So D is your answer. But again, I thought that was real nice that they actually gave you, I mean, it wasn't the answer, but it was nice that it was written on the paper there for you. You can like use that choice to help you. All right, and then these last two, we get a calculator for, which sometimes means you need it and sometimes doesn't. I think we're definitely going to need it here because I see all these decimals. All right, the figure above shows the graph of the polar curve r equals 2 plus 4 sine theta. What is the area of the shaded region? All right, this is your formula, and this is going to show up on the AP exam. They're going to ask you this to find an area of a polar curve. It's 1/2 alpha to beta, you know, starting point to ending point, r squared d theta. And so they gave us r. So to set this up, it's going to be 1/2, and then this 2 plus 4 sine of theta squared d theta. All we really need to find out are the boundaries. And it's going to be from right here until right here. So both of those points are where this curve equals 0. So what I would do is just off to the side here, we're going to take this 2 plus 4 sine of theta and set it equal to 0 and solve that. The other thing you can do is put your calculator, because you are allowed a calculator for this one, is put your calculator into polar mode and graph this and calculate that intersection. But I think it's honestly, that's so much button pushing. Also, it's going to give it to you as a decimal, I think, not as pi. I think it's honestly just easier to solve this. So subtract over the 2. And then divide by 4. So that'll give us -1/2. And so we want to find places on our unit circle where sine is -1/2. Now, sine is the y value, so they're going to be down here. We're going to get triangles in quadrant 3 and quadrant 4. So sine being the y value, I'm going to put the -1/2 where the y value goes. And so both of those reference angles would be pi over 6. And so the amount of rotation to get there, this one would be 7 pi over 6, and this one would be 11 pi over 6. And so those are your two boundaries for that. So then we're going to type this in the calculator. Let me make sure I'm in radian mode. You don't need to be in polar mode to type this. And in fact, you can just type x instead of theta, because we're really just trying to type in this integral. So 1/2 integral from 7 pi over 6 to 11 pi over 6. And then you have to start your own parentheses, because these parentheses that are given by the calculator are going to be around the entire thing. So you still have to put your own parentheses so that you can then square that. It's going to have to all be inside of there. So 2 plus 4 sine of, I'm just going to put x, close parenthesis, and then squared, and then dx, and that will give us our answer. So 5.960, they always round up though, so 5.961. Oh, what did I type wrong there? Oh, I typed a 1 instead of a 2. Let me go back and fix that. There we go. But I just typed a 1 instead of a 2 by accident there, and the whole thing came out wrong. Now, if it's multiple choice, you can catch that like I just did. If it's free response, you're not going to catch it though, which is a real bummer. All right, there we go, 2.174, so A for that. All right, and then lastly here we have the function f has derivatives of all orders for all real numbers. It's known that, right? And then they give you this for, you know, a 4th derivative and a 5th derivative. For 0 to 2, let p sub 4 of x be the 4th degree Taylor polynomial centered around 0. And the Taylor series for f centered around 0 converges at 2. So they give us this x value of 2. Of the following, which is the smallest value of k for which the Lagrange error bound guarantees that all of this is less than or equal to k? Right, again, this is a thing I don't expect you to walk around knowing, but you're going to want to look it up before the AP exam. I'm going to write out this Lagrange error bound. And remember this first part, I don't remember when you did this because it was months ago, this z value, you can't get exactly because otherwise it wouldn't be an estimate. You'd be able to find it exactly. But that's why they give you these, like they're going to give you a workaround in the problem. But what it's important to remember, and the alternating series error bound is like this too, you always do the n plus once. So you always go one further. So since we have a 4th degree polynomial, we're going to use 5. Like all of these, if we plug in 4 for n, 4 plus 1 is going to give you 5. So these are all going to be 5. So this is an extra piece of information. We're going to use the one that has the 5 in it. So we're going to use the 3/2. So they're kind of trying to trick you there or just test you on knowing which one of these you wanted to use. So that 3/2 is going to go in for this part. They gave you, 5th derivative of some value. Again, we can't get that. They're telling us that this is 3/2. So 3/2 for that part. Times x minus c. Now they gave us the x value is 2 and we're centered around 0. So that's going to be 2 minus 0 to the 5th. Again, n was 4. It was a 4th degree polynomial. And then so same thing here. This is going to be 5 factorial. And I think they wrote it in a bit of a different order, but it's going to be 2 to the 5th and then over 5 factorial and then times 3/2. So that's the first one. So it's going to be A. All right, so those were all the BC problems. So I'm going to go back to the beginning and just do as many of the AB problems as I can get through. All right, so first one, limit as x goes to 0 for this. Now, if you plug in 0, cosine of 0 is 1. 1 minus 1 is going to be 0. And then down here, you're also going to get 0. So this goes to that form 0 over 0. And so we're going to need to do L'Hopital's rule, which means we're going to take the derivative of the numerator, derivative of the denominator. So derivative of 1 is just going to be gone. And then this is a chain rule. We're going to bring the 2 down. So it'll be -2 cosine. It's going to drop to a 1, which you can put in there if you want, of 2x. And then we're going to have to multiply on the derivative of 2x. Or no, I'm sorry, I skipped one. We brought down the 2. Now I have to chain on derivative of cosine. Derivative of cosine is negative sine. And then I can chain on the derivative of 2x, which would be 2. So actually, I'm just going to multiply that out front here. 2 times 2 would be 4. So yeah, sorry, there are 3 links in that chain. You're going to bring down the 2, drops to a 1. And then derivative of cosine is negative sine. And then derivative of 2x is 2. And I just multiplied on at the front. 2 times 2 is 4. So also those negatives are going to cancel. That'll be good. Over, and then this derivative will be a lot easier. This is actually 4x squared. So if we do that derivative, that would be 8x. Now, if we plug in 0, sine of 0 is 0, which causes that whole thing to go to 0. And then the denominator will also be 0. So we're going to have to do L'Hopital's rule again. And that's going to involve a product rule up here. So this one's going to be kind of longer, right? So derivative of the numerator, product rule, we're going to have the first function, so 4 cosine 2x, times derivative of the second. So derivative of sine is cosine, and then you'd have to multiply on a 2 for the chain rule. So it's first times derivative of the second plus the second function times derivative of the first. All right, so derivative of cosine is negative sine. So this would be -4 sine of 2x, and then chain on a 2, which I'm going to have to erase because I ran out of room there. 2 times 4 would be 8. So again, that was a product rule. First derivative of the second plus second derivative of the first. This is very involved for a multiple choice question. We had to do L'Hopital's rule twice, but it's going to work this time because derivative of 8x is just 8. So we're not going to get 0 for that. So let's see what we do get. Cosine of 0 is 1 times 4 will be 4. So that first part's just 4. And then this next part will just be 2. Because again, cosine of 0 is 1 times 2 is 2. Sine of 0 is 0. So this whole thing gets wiped out. And then over 8. So after that, the answers to the whole thing is 1. So D for that one. That was very involved for just a multiple choice question because we had to do that twice. But we got through it. All right, number 2, let f be the function defined above, so piecewise function. If what values of x, at what values of x, if there are any, because there might not be, choice D is differentiable everywhere. Where is f not differentiable? All right, we're going to have to check -1 and 2. So let me check -1 first. In order for the function to be differentiable, first of all, it has to be continuous. Like the two pieces have to come together and meet up. So let's check that first. If we plug in -1 to this piece, we would get -2. And if we plug in -1 to this piece, we would get 1 minus 3, which is -2. All right, so the function is continuous. Now we need to check if it's differentiable. So I'm going to need to do the derivatives at -1. So 2 over x, that it means 2x to the -1, if you want to write that off to the side. When you go to do that derivative, you're going to bring the negative down, so it would be -2. And then this is going to drop to a -2. So the derivative is going to be -2 over x squared. Because the exponent would now be, it would be x to the -2, and then that's going to come down to the denominator. So if you plug in -1 to that, you are going to get -2. And then we're going to do the same thing with this one. This derivative is going to be a whole lot easier. That derivative is 2x. And if you plug in -1 for that, you get -2. So the function is also differentiable there. So at x equals -1, we're continuous and differentiable. So anything with a -1 in it is not going to be the answer. All right, now we have to check 2. So first, let's check if this is continuous at 2. I have to check these two pieces. If you plug in 2 to this one, you get 4 minus 3, which is 1. And if you plug in 2 to this piece, you're going to get 8 minus 3, which is 5. So those two pieces don't even link together. So I don't need to check if it's differentiable. It's not continuous there. So it's not going to be differentiable either. So B for that. And I think I'm only going to be able to do one more. Is there one that you want to pick, or do you want me to just do the next one? Because I'm only going to be able to do one more.
I didn't notice any specific one when I was going through it, so I guess we can just do the next.
Just do the next one. Okay, that works for me. And I'll fill out the rest. Or actually, you already have the answers. I keep saying that, but you already have the answers. They're already posted. All right. So number 3, the table above gives values for the differentiable functions f and g and their derivatives. H is given by this monster of a function. Find h prime of 1. So we're going to find the derivative, and then we're going to plug in 1. So this first part is going to be a product rule. So it'll be first times derivative of the second plus second times derivative of the first. All right, so that takes care of that part, plus, and then this derivative would be 2g prime. And then basically you just got to go and gather all of those values from the table up there. All right, f of 1 is 2. G prime of 1 is 3. G of 1 is -5. F prime of 1 is -4. It's just like scavenger hunt here. And then this would be 2 times G prime of 1, which is 3. So you actually didn't even use this part of the table at all. That's like extra information. So this would be 6 plus 20. Negatives are going to cancel. Plus 6, so 32. So that one is A.